Not ready. Thank you for tidying up this mess. Yeah, thank you. Thanks. You're welcome. It is my pleasure. I put the triangles together, and I now made... what did I make? Well, it has 1, 2, 3, 4 sides, but I don't know what it is either. I can see you've tidied your mess up. Ooh, it looks like a new shape is formed by using these triangles. I formed a new shape? What four-sided shape is it? It is something called a trapezoid. A trapezoid is a quadrilateral that has at least one pair of parallel sides. This side is parallel, and this side is parallel. Ooh, that's cool. It is indeed very cool. Let me show you, and let me explain to you all about trapezoids. Trapezoids! Ooh, very cool shapes. Yes, I want to learn. Me too. Experiment with trapezoids. A trapezoid is a quadrilateral with exactly one pair of parallel sides. And in each of the trapezoids below, the dashed line forms two triangles. Like this, one triangle, two triangles. That makes a trapezoid. Wait a second. This triangle has a right angle. This is a right triangle. That is correct. And we could also split apart trapezoids. Here we go. Like this. Yes. And we could also see that the yellow trapezoid also splits into two triangles. One triangle, two triangles make one trapezoid. Ooh, wow, very cool. Yeah. And if we look very closely here, we could also see that we could split these like this. 1, 2, 3, 4, a four-sided shape. 1, 2, 3, a three-sided shape. 1, 2, 3, another three-sided shape. And 1, 2, 3, 4, another four-sided shape. Very cool. So there are four-sided and three-sided shapes hidden inside the trapezoid, which means we could split those shapes too. Ooh, very interesting indeedly. Yes, it is very interesting. The trapezoids below are exactly the same. What do you notice about this trapezoid? It has a side that is labeled. That's right. This trapezoid has a side labeled A. But this is the same exact one. So what do you think this side should also be labeled? A? That's correct. Because this side is exactly the same as this side. Very cool. We could show that the shape is a trapezoid because at least one pair of sides is parallel. we could show that they are parallel by drawing these arrows. At least one pair of parallel sides is parallel. Quite obvious. Now, since both of the sides are A or equal, we could assume that this is an isosceles trapezoid. Wait a minute. I know about isosceles triangles, but there's also an isosceles trapezoid too? Yes, an isosceles trapezoid has two sides of equal length and one pair of parallel sides. To make them equal, we just have to put tick marks. And it's an isosceles trapezoid. You will learn more about trapezoids and isosceles trapezoids in 9th grade. Cool! Yes, very cool indeed. And we could also split this one. And especially since it's isosceles, we could split it into a whole different way. If we look carefully here, a three-sided shape, a three-sided shape, a four-sided shape, a four-sided shape, a three-sided shape, another three-sided shape, a five-sided shape, a three-sided shape, five-sided shape, four-sided shape, and three-sided shape. We could see all these shapes hidden in this trapezoid. Pretty cool, huh? Yeah. Cool, cool, cool indeed. Wow! Yes. Trapezoids are a special kind of shape. Wait a minute! This is a different one. The trapezoid below has a midline that connects the midpoints of the slanted sides. What do you notice about this trapezoid? It has a little line that splits the trapezoid in half. That's right. This means that both of the sides are equal, although they are different sizes. Because at least one pair of sides is parallel. One pair of congruent sides is parallel. Why do I keep saying one pair of parallel sides? That is why that although the pieces are of different sizes, they are equal. And A is not equal to B, explaining why these are not completely congruent. They are just parallel. One pair of opposite sides are parallel. Opposite, that's what I was looking for. They are not congruent. They are opposite. And if we look here, this is the same as this. So this must be an isosceles trapezoid. Yes. And if we look here, this appears to be a rectangle hidden. We could also draw another rectangle. Yes, which really appears to be a trapezoid. Or is it a trapezoid? It's a rectangle now. And we could split this apart. And that apart. And that apart again. Woo! Yowzer. Yowzer. Woo! Wow! I like the pattern. Very interesting. Yes. Trapezoids could come in all shapes and sizes. Well, not shapes. Trapezoids aren't the same shape. Experiment with trapezoids continued. This is interesting. Very interesting. What do you notice about this trapezoid? There is a line that splits the trapezoid into two equal parts. That's right. Both of these are equal. Which means isosceles trapezoid coming through. Zip. Zip. Yes. These are equal. Which makes this whole trapezoid. Ha ha ha. Yes, which means that this must be equal as well. And this must be equal. Wait a second. What do you notice? Ooh, it appears that all four sides are of different lengths. And although they are of different lengths, they appear to be equal, but aren't actually equal. That's right! Because although this is absolutely equal to this is true, this is not equal to this. So, this is parallel. Ah! These are not equal to. So these are parallel. These are equal, but they are parallel too. Ooh! I think we are making good discoveries here. Trapezoids could have more than one pair of parallel sides as long as it is like this kind of shape. Which means we could also do the same thing for this trapezoid. This side is equal to this side. This side is equal to this side. And this side is equal to this side. Which means right angles and diagonals too. Here come the triangles. Wait a second. Let's check something. I think I noticed a pattern. A pattern. I see a pattern. The blue triangle kind of represents this. The yellow triangle kind of represents this. And the red triangle kind of represents this. These three triangles appear to make a trapezoid. The exact same one. That's very cool. Yes. And especially since all three triangles are equilateral, this means that all of the sides are equal. That's it. All of the sides are equal. Very, very interesting. Very interesting indeed, Ellie. But we have to remember that this is parallel. This is parallel. And this is parallel. Yes! Wow! Very cool! Trapezoids are a very complex shape. That's right. The height of a trapezoid is the perpendicular segment between its parallel bases. Trapezoids have heights. This determines how tall they are. Let's see how tall the orange trapezoid is. Let's draw the height. And the right angle. This appears to be a right triangle hidden inside it. Yes! This makes 1, 2, 3 triangles again, making it similar to this. Wow! And if that is not enough, this triangle also has a right angle. Yes. And since we have 3 triangles, we could split the triangles, which ultimately splits the trapezoid. Ooh, very cool. Triangle, 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 triangle. Oh my goodness, we see 1, 2, 3, 4, 5, 6, 7. 7 triangles! Oh my goodness! That is very crazy, I tell ya. And this trapezoid's height is shorter. Ooh. Because the right triangle of this one is smaller than the right triangle of this trapezoid. This right triangle is bigger than this right triangle, explaining why the height is different. Yeah! You could also draw the height of a trapezoid outside, like this. Ooh! Math could be very magical. So it doesn't just have to be inside the trapezoid. It could also be outside the trapezoid that you could find the height. Yes! We could also find the height here. Very interesting. And that is, hold on to your hats, also a right triangle as well. Oh my goodness. A whole new triangle has just appeared. Wowza. But then another triangle appears. And then another triangle appears. Wait a second. Did we just see another one? And the other one. There's another one too. Oh my goodness. We could make triangles forever in trapezoids. This is very cool. Yes, it is. Wow. Just look at how many triangles we found inside and outside the trapezoids. We found so many of them. Like so many. Wow. Trapezoids are very complicated. Yes, they are. Now we are going to calculate the area of this trapezoid. Let's recap. What is the area of a triangle? It is half times the height and base. Yes, that's right. Wait a minute. This is another triangle. Ooh. With another height. Wait a minute. We just need to add the area of this triangle and the area of this triangle to equal the trapezoid. 1, 2, 3, 4. Yes. Parallel. Parallel. Not equal, but parallel. Because this is longer than this. So yeah, you're right. HB divided by 2 plus AH divided by 2 equals the area of the trapezoid. And a triangle. Woohoo! A triangle over here, which means right angle, right angle. Woohoo! Yeah! Yay! This is very interesting indeed. We're making new discoveries over here. Wait a minute. We could split apart triangles. There's another one. And another triangle over here too. Oh my goodness. We are making so many new discoveries. Ooh. And another one here as well. Cool. A lot of things could be discovered in trapezoids. Very cool shapes. I agree. Wow. We just discovered a lot about trapezoids. Hang on, there's more. Wow! Rit, 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 rit. These triangles are equal. We're making so many discoveries. Wait a second. I could keep splitting these shapes all day. Yes, right. Right angle, and another one. Maybe I shouldn't have told Flopsy. Or maybe I shouldn't have told Flopsy either. Maybe neither of us should have teached that to Flopsy, because now he's discovering new things. Angle. A different angle. Woo! Yeah! I could keep annotating this trapezoid all day. Right. This is a triangle. Half of it! I'm so excited. That is gonna take him a while. He really enjoys trapezoids. Yeah. For a second, I thought he enjoyed triangles more. But now we know that triangles, simple figures that could look complicated, could also make more complicated shapes like trapezoids. Four-sided shapes. Yeah. Guys, make a cup of carrot coffee. We're going to be here for a while. All right, Angle. Very interesting. Wait a second. And if this is equal, which means this is behind two. I'm so excited. No, the trapezoid. Nah, it's okay. You like triangles too. Yeah, I do. Triangle party! Whoa! Sorry.